question 1 is asking us which equation has the same solution as the trinomial. So if you notice, all 4 choices are in the form that we would need to get into if we were starting to complete the square. So I'm going to start to complete the square. My constant. I'm ready for my next step. By adding the boxes, I'm going to take negative 6 divided by 2, square it. I get negative 3 squared, which gives me positive 9. I'm going to add 9 to both sides. When I factor the left side, it becomes x minus 3 times x minus 3, which is x minus 3 squared, and it's equal to 21. So that is choice 4. Number 2 is asking us for the zeros of the function. So zeros also can be called roots. They're asking us to solve for x. So when we're solving for the zeros of the roots, we make f of x or y into 0. So I'm going to replace y with 0, and I'm going to solve for x. So this would be the square root method. I'm going to add 25 to both sides. And then take the square root of both sides. Not forgetting that we have plus or minus at the square root of 25. So I'm going to get plus or minus 5 is equal to x minus 2. If I add the 2 to both sides, I get x is equal to 2 plus or minus 5, which is going to give me 2 solutions. X equals 2 plus 5, so I get one answer of positive 7, and x equals 2 minus 5, and another root of negative 3. So 7 and negative 3, choice 3 would be our answer. Number 3, we're being asked to solve this using the quadratic formula. So which of the choices would be the correct, would determine the correct solution? So what we really need to do is just get it set up. So we need to be in standard form when we're using the quadratic formula. So this would turn into x squared plus 8x plus 15 is equal to 0. Now I need to determine what a, b, and c are. So a would be positive 1, my leading coefficient. B is 8, which is in front of my x to the first power. And c is my constant, which is positive 15. Alright, the quadratic formula, x equals negative b plus or minus the square root, b squared minus 4ac all over 2a. I want to correctly substitute into that. So x equals negative b, which is 8, plus or minus the square root of b squared minus 4ac all over 2 times a. And if we look for the correct plug-in, that was choice 4. We're being directed here to solve a quadratic equation by completing the square. Okay, so it tells us that Sam arrived at this equation. Which equation could have been the original? Okay, so there's more than one way to do this. You could look at your 4 choices and complete the square to match this, or we could take this equation if we want, and we could multiply it out. So I'm going to use the box method here of x minus 5 over 2, x minus 5 over 2. If I multiply, I'm going to get x squared minus 5 over 2x minus 5 over 2x plus 25 over 4. Okay, so that's going to give me x squared minus, if I add like terms here, it's going to be 10 over 2x. My like terms plus 25 over 4 is equal to 13 over 4. Okay, and then if I get this into standard form, because all of my 4 choices are in standard form, I would be subtracting this 13 over 4 on both sides. And I can also simplify this negative 10 over 2 to be negative 5x. 25 over 4 minus 13 over 4 is going to give me 12 over 4, which is really 3. And this is choice 4.
Okay, taking a look at question 5, you want to look for a GCF first when you're factoring. So the GCF here is a 2, so I'm going to factor out a 2, so it's 2 times the quantity of n to the 4th minus 16. And I'm going to look at that n to the 4th minus 16. Both of those terms are perfect squares with a subtraction sign in the middle, so this is factorable like dots. Now I'm going to break down the 2 and the n squared plus 4 because they can't be factored further. The n squared minus 4 can be factored again by dots. N squared and 4 are both perfect squares with a subtraction sign. So this would be the expression factored completely, which should be choice 3. Question 6. I give you a graph and you have to find the correct equation. So right now you should see that the y-intercept on the graph is negative 5 and the slope is down 2 over what? down to over y. So the slope is -2. So if I'm thinking about the slope-intercept form of a line, which is y equals mx plus b, you should know the slope is -2 and the y-intercept is -5. So that's really the equation that you're looking for. So what you would have to do is try each choice and solve each choice and put it in y equals 4 to find the one that matches. So the correct answer is actually choice 4. Because when you go to solve this, say this is y equals -10 divided by 2 minus 4x divided by 2. In other words, each of these is being divided by 2. So y equals -5 minus 2x, which is in standard form, y equals -2x minus 5. Taking a look at number 7, we have a rectangular piece of paper. The length is 3x plus 2, and the width is x minus 7. And they want to find the total area. So area is length times width. So if I take 3x plus 2 and I multiply it by x minus 7, I can figure out what my answer would be. So I'm going to use the box method, but you could have also used the double distributing method. So 3x plus 2 and x minus 7. So I'm multiplying to get the values in the box. So I have 3x squared. And then I'm going to combine the -21x and the 2x to get -19x, then minus 14. So that choice should have been choice 3. Taking a look at number 8, we want to simplify this factor. So we want to find the largest perfect square that divides evenly into 250. So that would be 25 times 10. So 25 is a perfect square, so that becomes a 5. So now I'm going to multiply the 3 times the 5 to get 15 radical package choice.
Okay, for question 9, we're being told that if an airplane company is charging $150 per ticket, and they charge you an overage charge of $20 per bag after you exceed the initial 2-bag allowance. Right, so C is our cost, and B is representing the total number of bags. So if $150 is just your standard charge, that's not going to be attached to the bags, so I'm going to get rid of choices 3 and 4. So now I know if I'm paying $150 right away, and then I pay $20 only if I use more than the 2 bags on my flight, that means, let's say we brought 3 bags. So I'm just going to try both of these choices. If I had 3 bags, that means I have 1 extra. So in choice 1, that would end up being 20 times -1. So you'd actually end up you'd be saving $20, which is not what they're saying here. In choice 2, I would be adding that extra $20 times the 1 extra bag that I'm bringing. So choice 2 accurately depicts this cost. Question 10, we're being asked to solve this inequality. So you could maybe approach this more than one way, but I started by subtracting the 3/4 x on both sides. And if I do 2 minus 3/4, I get 5/4x minus 1 is less than 9. So then I add 1 to both sides to isolate my x term. 5/4x is less than 10. And then I want to get x alone, so I'm going to multiply by the reciprocal, which would be 4/5. Again, I'm multiplying by a positive, so I am not changing the sign of my inequality. And if I do 10 times 4/5, I get x is less than 8, choice 4. So now on to part 2. So for question 11, we were asked to subtract this trinomial from this trinomial. So this is the first trinomial, and this is going to be written second. So first off, I need to know to write that out in the proper order. And since I'm subtracting more than one term, I need to remember parentheses around my second trinomial. Now I'm going to distribute that subtraction sign, and I end up with 2x squared minus 3x minus 9 minus 7x squared plus 3x minus 5. Now I just need to combine like terms. So my x squared terms, 2 minus 7 will give me -5x squared. I have -3x and +3x. So they're going to cancel to 0. And then I have -9 and -5, which is going to give me -14. So the difference would be -5x squared minus 14. Question 12, they want us to determine and state which table represents a function, and then explain our answer. So to be a function, we need to know that every x is associated with its own unique y. So in choice A, I can see that both of these x values, 4 goes with 5, 4 goes with 9, 2 goes with 7, 2 goes with 3. So that's not a function. I look at choice B, and I can see that this x value of 0 is repeating with different y's. So that's also not a function. Choice C, I have 3 with 2, 5, 4, 7 with 2, and 9 with 4. So initially I can see that C is a function, and just to see that D is or is not a function, I can see that this x value of 0 is repeating with more than one y. So the first thing I need to do is I need to state that table C represents a function, and then it asks me to explain. So I'm going to say it represents a function because every x value has its own unique y value.
We have 10 minutes. Okay, question 13, we have to determine the roots of the equation algebraic. So really what you're asked to do is to solve. So it says to express your solution in simplest fraction form. So that should be a hint to you that this equation is not factorable. So you could have either chosen to complete the square or to use the quadratic formula. So I'm going to use the quadratic formula here. My a value, which is the coefficient of x greater than 1. My b value is a 4, and my c value is a negative 16. So we plug in the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now I'm going to simplify what I have. So x equals negative 4 plus or minus the square root of 80 divided by 2. So now I have to simplify that radical 80. So x equals negative 4 plus or minus. I want to find the largest perfect square that divides 80 into 8. 16, and 16 times 5 would give me 80. So the square root of 16 is a 4. So I get x equals negative 4 plus or minus 4 radical 5, and each piece is being divided by 2. So now I'm going to simplify. So I get x equals negative 2 plus or minus 2 radical 5. And that would be your final answer. Taking a look at question 14, Sarah and Alice go to the food court to purchase lunch for their group of friends. Sarah orders 2 burgers and 3 orders of fries and spends $19.75. Okay, so I'm talking about burgers and fries. So I need a let's see. So I'm going to say let x equal the number of burgers, let y equal fries. Actually, you know what? We want the cost for a burger, cost per fry. I need to read carefully. So I'm going to revise that let's see. Let's say cost of a burger and the cost of fries. So Sarah orders 2 burgers and 3 fries, and she spends $19.75. So I used X and Y for burgers and fries, but you could have used B and F if you want. Alice orders 5 burgers and 2 fries, and it spends $37. So 5 burgers plus 2 fries and spends $37. So we need to find the cost of each, and we can only solve algebraically. So since we have a system of equations set up, I'm going to use the elimination method because the variables are all lined up. So I'm going to take the first equation, and I'm going to multiply by negative 2. I'm going to take the bottom equation, and I'm going to multiply by 3. By doing that, I'm going to get rid of the y. So when I distribute the negative 2 on top to each term, I get negative 4x minus 6y equals negative 39. When I distribute the 3 on the bottom, I get 15x plus 6y equals 111. So now when I add up and down, the y's cancel out, and I'm left with 11x equals 7150. So I want to isolate the x. I'm going to divide by 11, so x equals 650. So that's telling me burger costs 650. So now I know how much burger costs. I need to know how much fries cost. So I'm going to plug into either original to solve for that. So I'm going to take my first original, 2x plus 3y equals 1975. So I know my x value now is 650 plus 4. Plug that in. I should be able to find the cost for y. So 2 times 650 is 13. 13 plus 3y equals 1975. So I'm going to subtract the 13 to isolate the y value. So 3y equals 675. And then divide by 3. So y equals 225. So that means fries cost $2.25.
So for the last question, question 15, we're being told that a rectangular flower bed has a width such that the width is half the length. So the first thing I'm going to do is start drawing myself a rectangle, and they tell me the width is half the length. So if the length is x, then my width would be half of that length. They also tell me that the area is 34 square feet, so I'm going to label that in my diagram. I'd be told to write and solve an equation to determine the width of the flower bed to the nearest tenth of a foot. Okay, so I know that using the formula for area of a rectangle, length times width is area. So if I multiply here, I just get 1 times 1/2 is 1/2, x times x is x squared, and that is equal to 34. Okay, so I'm set up for the square root method here. So I need to isolate what's being squared, so I could multiply both sides by 2 over 1. I get x squared is equal to 68. And now I'm going to take the square root of both sides with a plus or minus on the right. So I get x is equal to plus or minus the square root of 68. Okay, so we were told to now take this and round to the nearest tenth of a foot. So you could have simplified the square root, but you also could have gone right to the calculator. So we did take it one more step. 68 does simplify to be 4 times 17. So I get x equals plus or minus 2 times the square root of 17. If I look at my calculator here, I typed that in for myself. So positive 2 rad 17 comes out to be 8.24, and negative 2 rad 17 comes out to be a negative 8.2. So I'm going to reject the negative, because we're talking about width of a rectangle here. And I need to recognize also something here, that this is x. X is equal to 8.246, and so on. But I need the width. So the width is half the length. So if you take half of this number, then you should get approximately, for rounding to the nearest tenth, 4.9.